So we want to integrate cosine of 2 times x times cosine of x from 0 to pi over 2. And so there's a product, we don't know what to do, but we know something. So we can use maybe the addition formula for the cosine. So the quick reminder is that for all x in the real numbers, we have that cosine of 2 times x equals cosine square root of x minus sine square root of x. So maybe we can use that and plug that into the formula. So that would give us the integral from 0 to pi over 2 times cosine square root of x minus sine square root of x times cosine of x dx. So what we can do here is we can reformulate this by multiplying both cosine squared and sine squared with cosine. This gives us the integral from 0 to pi over 2 of cosine to the third of x dx minus the integral from 0 to pi over 2 of cosine of x times sine squared of x dx. So at this point we can use substitution for the right integral. So we can substitute sine of x, and for the left hand integral we can use, I guess we can use integration by parts. So let's call this I2 and let's call this I1, and let's solve both separately. So we have I1 is then the integral from 0 to pi over 2 of cosine to the third of x dx. So we can write this as cosine times cosine squared, and I think we should integrate the cosine. So that would give us the integral of cosine. The antiderivative of the cosine is sine, so we have sine of x times cosine square root of x from 0 to pi over 2 minus the integral from 0 to pi over 2 of sine of x times the derivative of cosine squared, and this would be 2 times cosine of x times minus sine of x. So we can write here plus and then put here a sine squared dx. So what we see now, this we can, so maybe let's have a look at the left side. We know if we plug in pi over 2 into this term, we get the cosine is 0. Cosine of pi over 2 is 0, so this is just 0. So sine of pi over 2 times cosine square root of pi over 2, this is 0. And then we subtract sine of 0 times cosine square root of 0, and here the sine is 0, so this gives us just 0. And then we add 2 times I2, right? This is just 2 times I2. So we have in the end, just 2 times I2. So now we have, we can reformulate I2, and not reformulate, we can compute I2, and we will do this by substitution. So we have the integral of cosine of x times sine squared of x. And as I already mentioned, we want to substitute sine of x. So we have phi of x supposed to be sine of x. Then we have phi prime of x is cosine of x. So this is perfect because cosine is already in the integral. And we have phi of 0 is 0, and phi of pi over 2 is just 1. So we get the integral from 0 to 1 over, let's say, z squared dz. And this is just 1 over 3 times z to the third from 0 to 1, so that just 1 over 3. So what we get in the end is, maybe let's call this integral that we initially wanted to compute, let's call it I. So what we have now is, we have I equals I1 minus I2, and we just got that I1 is equal to 2 times I2, so this is 2 times I2 minus I2, and this is just I2, and as we computed just previously, this is just 1/3. So we get that the integral from cosine of 2 times x times cosine of x from 0 to pi over 2 is just 1/3. Kind of not too easy, but in the end we got it.